In the previous videos, we learned how to use Google Colaboratory and TensorFlow for image classification. Today, we will see how to use advanced deep learning techniques for sentiment analysis and text classification. In the notebook we are going to analyze today, we will use a special deep learning technique called transfer learning. In transfer learning, we will take advantage of the characteristic of deep learning that allows to reuse pre-trained models as layers of our deep learning model. In this case, we will use a word embedding model that has been trained by Google on a large corpus. The model has 7 billion of parameters, difficult to train on normal computers. It will extract the text meaning with great detail. Using this model will also free us from the need of text preprocessing. It is not a problem in this case. We will use a dataset containing 50,000 movie reviews from the Internet Movie Database. The task that we will perform is the text classification, where we are training our model to distinguish the reviews with positive or negative sentiment. Let's see how to implement this in Python and TensorFlow. Let's start by opening your favorite web browser. Type collab.research.google.com on the address bar and press Enter. Let's open the Jupyter Notebook. Click on the GitHub link. Type P. Mengoni GitHub TensorFlow in the search box and press Enter. Open the file T12 Text Classification. Let's verify where our code is being executed. We will need a GPU. Select the Runtime menu, then change Runtime type, and check that the GPU option is selected. Click Save. Let's click Play on the first cell. When you execute the first cell, you will find a warning from Google. The Jupyter Notebook in this case is safe to be executed, so choose Run Anyway option. OK, now let's get to the code. After the licenses for the code, you will find a brief introduction to the transfer learning model. Execute next code cell and it will set up all the libraries used in this code. Press play on the next cell and it will download the dataset from the internet, and later split it in training and test sets. Execute next cell and you will find that the two datasets contain 25,000 reviews each. Print 10 examples of training data. It's a list of 10 reviews. Good and bad, as you can read. Print 10 samples of training labels. 0 for negative reviews and 1 for positive ones. You can compare the labels with the text and find an immediate matching between labels and the perceived sentiment of the review. In the next cells, we will build the model. First of all, we need to download and set up the transfer learning part of the model. Execute the cell. It will download the model with 50 dimensions. Create a hub layer for it. And print the results of the test with 3 reviews. As you can see, we have 50 numbers for each review that represent the semantic meaning discovered by the model. Now we will add it to our full classification model. In the next cell, we find the definition of the full model. It is a sequential model, with the transfer learning word embedding hub layer as first layer, followed by the dense layer with 16 neurons and the ReLU activation function, and the final classification layer with 1 neuron, that will return 0 for negative reviews and 1 for positive ones. In the next call cell, we will define the optimizer, loss function, and evaluation metrics. Like in previous video, we will use the ADAM optimizer, binary cross-entropy as loss function, and accuracy metrics to evaluate the quality of the classification. In today's example, we will use an additional step for splitting our data. We will extract 10,000 of the 25,000 training examples for our validation set. By doing so, we will reserve the test set for the final qualitative evaluation of the model. Let's then train the model. Execute next cell, and the model will start to be trained. It will take a while as the dataset and transfer learning model are big. At the end of the training, we achieve 86% accuracy on the validation set. Let's check the performance on the test set. It's 84%. In the next cells, we set up a chart for the loss and accuracy over the training epochs. As you can see, the training loss value is decreasing, while the validation loss is increasing after 10 epochs. This is normal behavior, but our model is overfitting. It means that it's able to recognize very well the training data while failing with the unknown validation data. The same overfitting can be found for the accuracy. After 10 epochs, the validation accuracy does not increase. Let's try to use a 128 dimensions word embedding model instead of the 50 dimensions to see what happens. Let's go back to the model building cell. Replace 50 with 128. Then execute the cells until the training cell. As you can see, at the end of the retraining, the results didn't change compared to the smaller model. Still, we obtain 86% of accuracy on validation. By executing the test set evaluation, the accuracy is stable at 84%, and the graphical plots remain almost identical. In these cases, it is said that the model is learning how to classify the validation data. One solution is to stop the training early, in our case between 5 and 15 epochs. You can also try to change the transfer learning model and add additional hidden layers, but the performance will not improve too much. To get better results, we will need to change the deep learning approach. In this video, we have seen how to implement transfer learning using deep neural networks. We explored the Python code with the TensorFlow library. The final model can classify the sentiment of the IMDb movie reviews. Great work! That's all for today. Ciao!